Okay, so picking up where we left off yesterday. Yesterday we learned how to name them and put them in standard form, all that good stuff, find the degree, the leading coefficient. Today, in order to add and subtract polynomials, we just combine the like terms. So we can either add or subtract horizontally or vertically. I'll show you both methods and you can decide whichever one works for you best or whichever one you like more. So if I'm looking at two polynomials like this, and I can tell that they're two separate polynomials because I have parentheses around them, right? If I'm looking at these two polynomials, if I want to add them together, which there's a plus sign in the center, then what I actually do is combine my like terms. And so I can leave them in this form like this. And if I leave them in this form, then what I actually have to do is figure out what goes together. So basically, if I'm looking at like terms, I'm looking at the terms that have the same variable and the same exponent. So everything in here either does not have an x or has an x with a different exponent, right? So this 2x to the third would combine with the x to the third. I don't have anything that's x squared in the first one. So then my other ones are going to combine. The x and the 7x will combine. And then the 4 and the 9. Now this can look like a mess. And so what I'm going to show you is the easiest way to handle this is to start by putting it in standard form. So if I put it in standard form, that goes from the highest exponent to the lowest. So 2x to the third, then it would be minus x, and then plus 9. I'm going to do the same thing over here. Plus, I'll even leave the parentheses on them for now, x to the third plus 5x squared plus 7x plus 4. Now, because I put it in standard form, I don't have to search what goes with 2x to the third because I see that I have an x to the third right in the front. So 2x to the third plus x to the third gives me 3x to the third. Now if I look here, this is x to the first power. Here I have a 5x squared. So I don't have anything to combine with this. So I'm just going to rewrite it down here. Moving on, I have a negative x plus 7x. So that's really 7x minus x, which would give me 6x. And then last, I'm combining the 9 and the 4 because those are the same terms. So then 9 plus 4 gives me 13. And that's my final answer. So that's how I combine them. This is called a, that's horizontal combination. The other way that I could do this is vertically. So I'm going to make this all smaller. Doing it vertically, I start by combining the terms the same way I had before, or putting it in order from highest to lowest. I mean, so 2x to the third, then minus x plus 9. Now you'll notice I left a gap between 2x to the third and minus x because I know that there's a 5x squared in the other one. So then I do plus, put the other one in standard form again, x to the third plus 5x squared plus 7x plus 4. Now I have everything that I have to combine lined up vertically. So by leaving this gap here for an x squared, it makes it so that I can keep it lined up. So then it's just 2x to the third plus x to the third. That's 3x to the third. I don't have anything to combine with the 5x squared. So that just stays 5x squared. Negative x plus 7x gives me 6x. And then 9 plus 4 gives me 13. See, I get the same answer either way. It all depends on how you like to do it personally. I do the same thing with subtraction. I handle it the same exact way. So I'm going to start with my vertical method here. And I'm going to put it in standard form. The negative 2x squared comes first. Then you'll notice I don't have a term where it's x to the first, so I'm going to leave a gap and do plus 3. Now here I have a minus, so it means I'm going to flip all of these signs in this one to the opposite sign. So this would be minus x squared coming first. And it's minus a negative x, which would make that a plus x. And then distribute the negative to the 6 as well, minus 6. Now I just combine them vertically. Negative 2x squared minus x squared gives me negative 3x squared. I don't have anything to combine with the x, so that's just plus x. And then 3 minus 6 gives me negative 3. And that's my final answer. Any questions on this? Okay, this takes us into a word problem. So we have the cost of manufacturing a certain product can be approximated by f of x equals 3x to the third minus 18x plus 45. And this is where x is the number of units of the product in hundreds. So then it says evaluate f of 0 and f of 200 and describe what the values represent. So this says evaluate f of 0 and f of 200. So when it says evaluate like that, it means that if you notice all the change from this part of the problem here to here is I replace the x with a 0. So that's all I have to do in order to evaluate f of 0. It means that everywhere I see an x in the problem, I replace it with a 0. So then 0 to the third power remains 0. Times 3 is 0. 18 times 0 is 0. Plus 45. 0 minus 0 plus 45 is just 45. So that's f of 0. To find f of 200, same thing really. I'm just replacing the x with 200. So that's 3 times 200 to the third power minus 18 times 200 plus 45. So now I'm going to get out a calculator because, you know, I don't know what 200 to the third power is off the top of my head. Sure, I can figure it out, but so I have 3 times 200 to the third power minus 18 times 200 plus 45. That gives me 239 964 45. And so what this tells me is, it says we have to explain what these are. X is the number of units of the product in hundreds. So this means that if I'm producing 0 units, then my cost is $45. So even if I don't do anything, my cost is $45. And this is if I produce 200, but it's the product in hundreds. So you would be adding 2 zeros to this. So then this would be if I make so I'm adding 2 zeros. I make 20,000 units. The cost will be $23,996,445. In other words, a lot of people will look at this stuff and say, well, I don't understand how this applies to me. If I'm actually looking at producing something, I need to get more out of it than what I'm putting in. If it cost me $23,996,445 to produce 20,000 units of something, then I would need to charge more than that. Why would it cost me $45 even if I don't produce anything? Well, there's underlying costs that will always be there no matter what. Even if my doors are closed on the building and I'm not doing anything in there, there still could be emergency lighting running, which would cost me $45 a month, or a lot of different associated costs with it. Maybe the cost of renting the building, that would all be added into it. So it's just something to look at as we move forward. Is the word problems are kind of our applications to what we're learning, where this comes from and where it comes into play at, and how it could possibly help you in the future. All right, well, there will be a homework assignment on this stuff from yesterday and today, and then we will move forward.